All right, welcome back. We finished up our basic derivative rules last time. And before we get into some more derivative rules, and we definitely are going to do a lot more, we need to pause and look at one of the applications of differentiation. One thing that it allows us to find early on. And so we begin here by discussing what are called marginal functions. And so consider the following situation here, where we have a function that tells us the cost of manufacturing some item. So in this particular problem, our function is 10,000 plus 90x minus 0.05 x squared. In this problem here, x represents the number of fuel tanks that we can manufacture. So some type of fuel tank. And C here is the total weekly cost. Now, a couple of observations here. Well, we're going to answer a simple question first, because we want to understand something here. Let's compute C of 0. And we want to know, what does this tell us? Well, C of 0 is very easy to compute. Plug 0 in for x, right? All the variable terms just drop out. And we get C of 0 equals 10,000. Well, what exactly is that? Well, this is telling us if we manufacture 0 fuel tanks, the cost is 10,000. How in the world are we having a cost if we don't make anything? Right? Well, those are the costs that we have to put out just to have our business. Those might be our property taxes, our utilities, insurance and other things like that that we have to pay whether we actually make anything or not. Right? These are our fixed costs. This is our fixed cost, $10,000. In every situation that you deal with costs can pretty much be guaranteed to always be your fixed cost plus your variable cost. Probably the simplest example is you go and get a part replaced on your car, right? And you pay for the cost of the part, that's your fixed cost, plus the cost of the labor to have the part put on. Pretty much everything, in some way or another, can always be divided into fixed plus variable. So in this problem, the 10,000, that's our fixed cost for our business. And the other part, 90x minus 0.05x squared, that's the variable cost, which is going to change based on how many units we actually produce. Okay, so that's the first thing I just want you to understand. In any cost situation, we always have fixed plus variable cost. It's just every single time it's always going to come out that way. Okay. Now, let's go a little bit further here, and let's compute the cost, or let's compute C of 350 and C of 351. Okay. So we're just going to go to our calculator, plug in 350 into our function, and get an answer. So my function again was 10,000 plus 90x minus 0.05x squared. So I'm just going to simply go into my calculator here. 10,000 plus 90x, 90 times 350, minus 0.05, excuse me, dog's barking. Sorry, dogs had to bark at people walking down the street. So 0.05 times 350 squared. So that we get a cost of $35,375. $35,375. Right? And we did the exact same thing, plugging in 351. And I'm just going to go in and do a little edit, save myself some time. 351 and 351. And we'll find out the cost of 351 is $35,429.95. So the C of 351 is $35,429.95. And of course, we could compute the cost for any other ones of those as well. So that means if we make 350 items, it costs 35,000 something dollars. And if we make 351, it costs 35,429.95 cents. So then we come to what we really want to know, and that is, let's compute C of 351 minus C of 350. In other words, we want to subtract those two things. We want to subtract those two answers that we just got. 35,429.95 minus 35,375. And when we do that, we get an answer of 54.95. Right? That's equal to $54.95. Okay. That number right there is the cost of making the 351st fuel tank. Cost of making the 351st fuel tank. Right? Because the first was the cost for 350 fuel tanks. Now for 351. So what we have when we do their difference is exactly just the cost of making that 351st fuel tank. That's referred to as the marginal cost. The marginal cost. Right, that's referred to as the marginal cost. Okay. Now I want to do one more thing here. Because that marginal cost, we weren't too bad on it. But there's actually an easier way to do it. There's actually an easier computation we can make, I should say. the actual, if we wanted exactly this thing, then what we've just done is what we need to do. But I want to compute something else. And I want you to notice that it's almost exactly the same. Almost exactly the same as what we just came up with. And so I want to compute C prime of 350. In other words, I want to go in and take the derivative of that function that I had up there and then evaluate that at 350. Evaluate that at 350. So take my function up there. Fortunately, it's a really simple function that we're dealing with there. 10,000 plus 90x minus 0.05x squared. We want to take its derivative. So that's pretty easy. 10,000, derivative of that is 0. 90x, the derivative of that would just be 90. And with the 0.05, we'd multiply by 2. So we're going to end up with c of x equals 90 minus 0.10, or just 0.1 if you want, x. All right, that is my c prime. I should say not c. C prime. That's my derivative. It's just 90 minus 0.1x. And that took like just a couple seconds to do. And now we want to evaluate that at 350. So if you go into your calculator, 90 minus 0.10 times 350, and that spits out an answer of 55. So I want you to notice here that this answer, $55, that derivative, that's telling me that the rate of change, remember derivative is a slope, rate of change of the cost with respect to the number of units produced is $55. That tells me the cost is increasing by $55 per unit produced, which is darn close to what we found as our marginal costs. And so this is the actual marginal cost. But what we do is we use the derivative to approximate the marginal cost. Because this now approximates the marginal cost. It's almost exactly, it's off by 5 cents. But it's something we can compute a whole lot quicker. So what we do in these problems when we talk about marginal something, whether it's cost, profit, revenue, or just about anything else, that always means do the derivative. That's going to always mean look to the derivative. So in these problems we're going to be looking at, we're going to have stuff dealing with marginal A, B, and C, and we're going to apply that to the derivative. Okay, so that's where we're going to be headed at with these kinds of problems.